Here's an overview of the harbor that we sail in. So our boat is down there. Don't turn so much, bring us out. Yeah, it's good. Now turn. If you turn too quickly, you're going to get too close to the other boat there. Sail is up. Bear off and get the wind in the sail if you want. Okay, hang tight for a sec. There we go, thank you. I'm not too sure what the occasion is, but HMCS Haida is dressed up today as we leisurely sail past at 2 knots. Hey everybody, so just trying out this new camera. It's not new, it's a work camera, but it's a Panasonic Lumix. And right now, behind me, I'm cooking some, I'm boiling some water, and I'm going to be making myself a tea. And I just kind of wanted to point out something that's really interesting about the boat. That's actually my my power, 93%. I'm boiling water. So this morning we made pancakes. We cooked, and overnight all the electrics were still running, so I use about 30 watts for everything in my boat all the time. So usually at night you wake up in the morning and I use right now about 15 to 20% of my battery. So so when I started my my quest here on my boat, I started out with one panel just to try to top up my batteries. It was a 100-watt panel, and I thought, man, this is great. I've got so much power now. That's basically how I do my tea here on the boat. Let that sit for a few minutes. I was just saying that I started out with 100 watts of power, and then I thought it was amazing, and it was good, but it was really just enough to top up things. I was consuming 5 amps, if I remember right, with my incandescent light bulbs. So I went on a quest of changing everything to LED here on the boat to drop off my power consumption, and it still was not good. And then I said, okay, I'm switching to electric. I made the decision. So I said I need more power, so I bought 3 more panels, and I ended up with 400 watts of power. You know, I got asked a fair amount of questions about it, and it's straightforward, but it's not straightforward. Like I just need to have a little bit of knowledge about electricity and things like that. So I'm going to just walk through some of the core systems here today. Yeah, we're doing really quite well. We've got 7 knots of wind and 5 knots of boat speed. So going upwind, we're beating into the wind here at about 50 degrees, 48 degrees. And David's feeling the power of Sunday morning here. We were coming back through the canal, and we had a pretty stiff wind. There was 20 knots of wind and current coming out, and it's actually quite far. It's about almost a half a mile of motoring, and then they don't want you kind of hanging out in there, so I try to keep it above 3 knots. So I was actually pushing it quite hard. I think I was close to I was at about 50 amps draw, so I was getting up there. But anyways, right at the very end, my controller had overheated, and I started getting some loss of power, and then all of a sudden it shut off, and I ended up having to sail out of the last little bit of the canal. But I just wanted to comment that under normal operating, I think I probably would drive an hour at 3 knots, and I was probably getting close to where the controller would be close to overheating. So never really encountered that. I said, well, I better put liquid cooling in and see what that did. So I did a whole pile of experimenting, which you can watch in another video. So we basically have 2 pumps for redundancy, and then what it's doing for us is it's keeping us safer in the long run. The motor temperature I'm finding is less than 40 degrees now pretty consistently, and even the controller, I haven't seen it, like just with regular motoring that we do, ever go above 37, except for on a high test that we did. We pushed it at 3,500 watts, which is like more than the boat needs. I couldn't push the boat any faster. I was doing 6.5 knots on the things, and I was feeling a ton of prop walk, the wash over the rudder. So I would never do that. And it went, it overheated. It didn't overheat. Sorry, it went all the way up to about 87 degrees, and it held there. And I think the cutoff, where we have it set now, is 100 degrees, 120 degrees. It cuts the power down. At 120 degrees, it cuts it down again to a second level, and it kind of limps. And then if that doesn't do it, it shuts off at 150 degrees. So I'm at 80. It was about 87 degrees, 90 degrees, 85 degrees, 92 degrees. So it's kind of in that range, running at 3,500 watts, which, like I said, was like just a lot. But it gets there pretty quick. So how do you get rid of the heat? So now that you've got water or liquid cycling through the pumps, I'll show you how I get rid of the heat. David's in his perch.
There's a buoy right in front of us.
It's buzzing science. It's great looking lines.
So what we did here to boost our speed by quite a bit is we attached a block right down below the end of the sail, and then we ran a rope through it, and then basically whenever you pull that rope, it pulls the end of the sail tighter downwards, and then it just tightens up the sail, and then it makes the top more tight, and it uses pretty much all the sail when you do that, and it adds a lot of speed.
Everything looking good up there?
Pardon me?
Everything looking good up there?
Yeah.
Nothing in the way? 2, 1, jibing to port. I'm going to do a slow jibe. Catch us as we do the corner here. Okay, go ahead. It's cutting over. Don't let it go all the way this time. Pull it. There you go. Good job, David. Forgot one of the lines. Thank you. So we had F2, 18.5 knots today. 8.12 knots of boat speed, so we had a couple of good gusts out there. You know, when we first went off, the boat transducer didn't read until we got going. It's kicked in again at 3 knots, so it's got some algae on it again. Seems like the never-ending battle. But we're going to have to pull that transducer out in the water, give it a clean with the scrub brush, and then put her back in. We'll see how that goes. Industrial PPC, Noctua F12 industrial fan, 3000 PWM pulse width modulated fan. And I'm just going to open it up here. Ooh. So these are just basically computer fans of some sort. So it looks like it comes with a nice little package. And it's got some screws. But basically, there it is. So it's a 120 millimeter fan. It does maximum is 3000 RPM, so this is way more. 186 meters cubed per hour of airflow. And the noise is 43 dB, so it's pretty quiet. And it will take 3.6 watts and 12 volts. So it's 0.3 amps. So with 3 of them, it'll be using 1 amp. This is at 12 volts. So on my 48 volt system, that was really divided by 4. So 1 amp will be 0.25 amps. So the bigger thing, I think, is the 3.6 watts per fan. That's pretty small. The other fan I have in there now is 12 watts. So I'm going to see a pretty significant decrease. But this 186 meters, if I remember right, that was like 120 CFM in the calculation. So I'll figure out what that is. Here it is here, IP52, this fan. So it can get a little bit wet, it can work with dust, and it's still okay. They have a version of this which is IP67, but I didn't end up buying that one. So I just thought I'd try this one here because it's going to be mostly dry anyways. So I'm using between 17 and 22 watts, and we're going to change out this fan. David, could you turn on the fans and the pumps? And we'll see what we're going to generate. Should be over 50, but we'll see what happens. I'll get everything else off. Okay, so David's got it on. And now you can see that jumped up to 66 watts. We've got 61 coming out of the batteries, so it's pretty consistent here, 66 watts. So we jumped up basically about 40 watts, because it was 17 to 22, now we're at 66, so let's just say 20 to 66 is 46 watts. Okay, all right, let's go change out that fan. So this here is the fan I'm taking out, and I'm replacing it with this fan here. And as you can see, this fan more closely resembles these ones, but these ones are just sort of standard fans, and from a computer. And this one here is industrial, so it's made to be dusty, wet, get wet, and all that kind of stuff. This one will go here, and plug it into there. Now when I turn it on, significantly more than these little ones. Yeah, I can feel it, the difference. Also, I like these little rubber, they have little rubberized components on them. And can you believe the mean time to failure on this thing is 150,000 hours? That's just awesome, eh? They're also, apparently they're designed to run right next to something. Some fans aren't. And that's my suspicion, is that the fan blades on this one just are not designed quite right. So what happens is that when you put it against the radiator, you know what, I don't even know if I have this going the right way. Let me just take a look at it. It's backwards to the other ones. David, I did this again, eh? I think I put it backwards. It was still blowing out more than the other ones. Isn't that wild? It's because the power's on the opposite side, so the fan blades are reversed. Yeah. I think, let me just take a look at it now. I'm pretty sure. That's the difference, eh? Look at that, eh? Wow. That's why we gotta switch to these fans. The difference is 3 watts versus 1.7 watts, so it's using twice the power. But still, it's significant. In here, so now we're popping between 55 and 61 watts with this fan. So this middle fan drops the power down from 66, so it's 5 watts less than that bigger fan. So there we go. And this one. So those Noctua fans are definitely stronger than the other ones, big time. So again, thanks for watching. We appreciate all the comments and thumbs up, and please subscribe to the channel if you like these videos. Really helps us out. We appreciate it. And make sure you hit the notify bell so that you know when our next video is online. So anyways, thank you. We'll see you again. And yeah, David's going to be setting up to do a time lapse, so maybe we'll end off this video with a nice time lapse of the sunset. Oh, hey guys, I just wanted to do this, I guess, review of the VRM from Victron Energy. This year I've gotten this new component to, I guess, my electrical and power systems,